My name's Tearle. I work for a company called Arista. I do Wi-Fi. I've been in the industry a few years. And the point of my conversation today is why work harder when we can work smarter, okay? So I have to thank Tom. Tom came on the stage yesterday and he put a slide up and he said, Wi-Fi is like a highway. Thanks, Tom, because that made my slide a bit easier to introduce. And then Dave Coleman came along and said, hey, Wi-Fi is like a freeway. Thanks, Dave, it made my life even easier. So what I'm going to do is I'm actually going to just quickly talk about this slide because Wi-Fi is like a motorway. If I add more devices onto a network, it gets more congested and I start seeing issues on the Wi-Fi. At 2 o'clock in the morning when no one's on the Wi-Fi, I get to travel a lot quicker. Couple of things to take from this slide. You can see that we actually only have 3 lanes in the UK. We don't have lots of space, so we can't build really big superhighways. And one of the lanes is actually empty at the moment. And we'll come on to why that's important in a minute. But what's more important on this slide than anything else, this is the right side of the road to drive on. Okay? We'll get that cleared off now. So, when I have a laptop or I have an iPhone or I have any type of device, it has to go through what we call the client connectivity journey. So what I need to do is I need to make sure that when I go to work and I get in my car, I have the right legal requirements. So I've got the right type of MOT on the car, I've got the right insurance. My tyres are legal. From our perspective, we have the association limit, we have a capability mismatch. So if I was to take a wide lorry onto the motorway, that could almost be a capability mismatch. If I don't have the correct legal requirements, I can't do the association. When we move on to authorized, if I'm driving a car, I have a specific type of driving license. If I drive a lorry, I have a specific type of driving license. It's the same with being authorized to the network. If I don't have the correct credentials, I fail my authentication. I've also got to make sure that my vehicle is maintained. It's got oil in it. So when I talk about oil, I'm talking about getting my DHCP addresses or my DNS. But the object of this journey is to either send my emails, do my work, do my voice calls, or transport a packet from A to B and do my job. And on that note, many years ago, when I was a lot younger, and I was a young Wi-Fi engineer, I had a phone call from one of my directors who said, you will drop everything that you're doing right now, you will get in your car, and you will drive from North London to a place called Dover. And it's a lovely place, apart from when there's a headmaster jumping up and down saying, the Wi-Fi doesn't work. So I get in the car, I spend 2.5 hours driving there, I sign in, and because I'd been to the site before and I'd installed it, my device is already on the network. So I was already connected. I walked up to the headmaster's laptop and I typed in the pre-shared key. And like magic, it all worked. How many people in this room have had that problem where you've had someone with fat fingers? You know, we've seen a lot of it, and it's a hard thing to troubleshoot over the phone. It's a hard thing to do without doing some form of packet capture. And some of these end users, they don't want to take part in packet captures and turning it on and off again, and how many bars do you see? I then got in my car and I drove home, which took me another 3.5 hours. So really, I took 6 hours of my day wasted sitting in a car. It's not a good use of our time. It's not a good use of our intelligence. So how do we do this? How do we make Wi-Fi better? So if we look at the roads again, in the UK, we're actually trying to build what we call smart motorways. And you'll notice on that sign, it says March 2019. I guarantee you it won't be March 2019. It's probably going to be March 2025. But now what we're doing with our motorways is we're using the cameras, we're using the sensors, we're using clear signage to actually try and help us develop our journey. So over time, we're going to build up using those cameras a view of the network, a view of the motorway, and we can see when it's the time to use the right lanes, and if we look at this picture, we've got 3 lanes there that are being blocked, and they're all clear, they're ready to go. But there's one with an X on it. Well, what that is, that could be a really bad 2.4 gig Wi-Fi network. And I don't want you to connect to that network at the moment because it just wouldn't be effective. So by using cameras, monitoring, sensors, I can actually build a motorway network that's more efficient. Because in the UK, as I said before, we don't have the space to build super highways. So how do I make this relate to Wi-Fi? So, I said I worked for Arista, which was Mojo, and we did some very, very clever things with the access points. Because what does an access point do? A lot of the time it's listening. It's taking packets, it's transmitting packets, and it's learning. But I've got nothing really to back up that information that I put through the access point. So if we look at what we do, we have something called a ring buffer. So we have a lot of memory within our access points. What that allows us to do is this. I can actually capture 200 packets per client. So that when I'm having a conversation on the network and I fail we'll use the 4-way handshake. It's a prime example. I failed the 4-way handshake, and as we can see from packet 5, there's a problem. Now what I do is I take that automatic packet capture and I store it. I store that for 30 days. So this allows me to do a couple of things. So when I get that phone call, because we've all had the phone call, the Wi-Fi doesn't work, it's the end of the world, I need you to fix the Wi-Fi now. I don't go, could you turn it on and off again for me, please? Can you just move outside the classroom and see if it will connect to another AP? No, what I do is this. I take the MAC address, or I take the asset number of that device, I type it in, and it actually allows me to do this. I can look at the system, I can look at the client journey, and I can see exactly where you are failing on the network. This is real time. I can tell you when a client has failed within 10 to 15 seconds. This is a real customer of ours with 29,000 clients on it. And as we can see, we've got some association issues, we've got some authentication issues, we've got some network failure issues. But I've got 27,000 odd clients that are on the network and they're working. With our system, what we can do is we can drill down into that floor area, because to try and scroll through 485 clients to find my problem is silly. So I can do 2 things. I can type in the MAC address again, I can type in the asset number, or what I can do is I can drill down and say, right, oh Ian, you're in England. What office are you in? You're in the London office. Now I drop down into those. It's a multi-tenanted system that allows me to manage multiple sites. Our largest customer has 183,000 access points on a single system across the subcontinent of India. Try troubleshooting that. You need to be able to drill down into it nicely. So, let's have a look at a failure. Do I have anyone in the room called Robin? There's probably no Robins in the room. But Robin's rung up. Robin says, I can't get on the Wi-Fi. The Wi-Fi's rubbish. Can you fix it, please? So I type in Robin's iPhone. You can see that he's connected to the network. He's tried to connect. He's actually done his association. But the problem is he's typed in the wrong password. Now what I do is I send him a screenshot saying, you typed in the wrong password. Because however many times we tell them that they typed in the wrong password, they don't believe us. Many years ago, I was on a course. I had the great privilege of doing the CWAP beta course in Atlanta. And one of the things I took away from that is the packet never lies. So now I've got this information and I can prove it to the customer that actually you're having a fat finger moment. We have a conversation and I said, no, it's not a 0, it's an O. Let me fix it. So now we're working smarter. Now I'm not getting in the car. Now I'm not doing packet captures. I'm not doing anything. It's all automated. It just works. So, on that note, if we look at this, again, with that ring buffer, you can see that I've got low RSSI, I've got low data rate. There's a young lady in this classroom somewhere that I had the privilege of doing the CWDP with. One of her problems is sticky clients. Sticky clients are horrible. But how do we find out that you've got sticky clients? You've got to go digging around, you've got to do packet capture, you've got to work out what AP they're... No, with our system, You select sticky clients, you see your list of clients, and thank you very much, I select my clients, and now I have a packet capture. It's already done. I'm not guessing anymore. Okay? And again, we can see the average latencies as well. Latencies are quite important nowadays, because if I'm doing AAA across WAN links, well, if I can't authenticate to the network, then I've got a problem. So, I think I've broken my clicker. No, I haven't. So, I'm not going to take the glory for this slide. This was written by one of my colleagues, a guy called Robin Jellum, and I just really like the way it was explained. If anybody is sensitive to flashing lights or anything like that, at one point you may need to turn away. So, in Devin's eyes, radio resource management is bad. But if you leave it automatic, you want to use it. You have to go off, you do a bit of background scanning, because background scanning is becoming more important. Because if I'm doing voice over IP and I'm doing 802.11k, I need to do the neighbor reports. So do I want to turn background scanning off? Not really. And I've got to do WIPs. WIPs is not something where you just take a snapshot of the network. You want to be protecting your network 24/7, 365. So, this is what everybody else does. And I'm praying this works. So I'm going to throw this up on the screen, and I want you to tell me what it is. You all saw that, didn't you? Yeah. Anyone tell me what that image was? Anyone got a clue? Okay. Our eyes and our brains are not as quick as a chip or a computer. But that split second of going off and looking at that channel for that point in time may mean I miss things. So this is what we do, and this is what we do differently. We have 4 radios in our APs. We have a 2.4, we have a 5 gig, and we have a BLE. But I also have a software definable AP in there. That software definable AP actually goes off, and instead of just taking snapshots, it's running a 24/7, 365 video of the network. Now I can see that someone's attacking my bank. Someone's being very, very naughty. Now what I can do is I can start doing procedures to quarantine and move them away. So I think that's quite important, and it's really nice. And actually, other companies do the same sort of thing. Sorry, I'm a little bit nervous. That's why I'm taking lots of water. So, but if I can take that third radio, now I can be proactive. Let's say I've got 300 schools, or I've got 500 bank branches, or I have 200 stores. I want to be able to run a test every morning at 7 a.m., and I want to be able to test the association, the authentication, the DHCP, I want to test the network. I want to prove the network's working before I go to work. And if I'm managing that network for you, via an API call, I'm going to send an engineer onto site and get that network fixed before you know there's a problem. In this case, we can see it's actually a Cisco WebEx failure. And yes, we have a DPI in our APs, so we can be application aware. So that now means I'm not going to waste a Wi-Fi engineer's time. I'm actually going to escalate it to the correct team. But I can also be reactive. Because when I get the phone call, the Wi-Fi doesn't work in the classroom, I don't want to run across the campus. I fixed the site in Belgium from my desk by doing this in 4.5 minutes. I didn't have to do anything silly. I didn't have to get in a car. I didn't have to take all my packet captures with me. This is there to be proactive, but also to validate user issues. So now we're looking at working smarter, we're not working harder, we're not wasting our time or our precious resources by doing silly stuff. I don't want to send an engineer in a van to fix a problem with a pre-shared key. I don't want to send an engineer in a van because when they changed the switch at the weekend, they didn't configure the correct VLAN on the new switch. And that's why the guests or the corporate network aren't getting the DHCP addresses. We've had lots of conversations about machine learning and AI. I had a conversation over breakfast with a guy from Eapol and Devin, and basically I took lots of words out of my presentation because we were using machine learning and AI and all these things, and Devin was like, no, don't do that. So I didn't. But then I heard Scott, and Scott was talking about machine learning. So this is what we do with our application health. We don't just say to you, oh, it's voice, video, best effort, and background. What we do is we look at the application. So using machine learning, we have gone off and we can tell you what is a good session and a bad session on both the Wi-Fi and on the wired network. So now, what I'm doing is I'm actually looking at the network, machine learning, building a model, and saying, right, that session's bad. Because if the application isn't working, then that's just as critical as the Wi-Fi not working. Large corporates using Skype need to know this type of thing. They need to know whether the sessions are working or they're not working. So, and I'm doing really well on time. So I've got a conclusion. I'm sorry, I'm British, I'm slightly quirky, and I conclude in a kind of interesting way. So, in my access point, I've shrunk down loads of Captain Americas. Because Captain America is a good guy. And he's going to protect my network 24/7, 365. So what I need to do as well is I need Dr. Strange, because Dr. Strange has this time stone. Because what Dr. Strange is going to do for me, he's actually going to capture all these packets, he's going to store all these packets, and he's going to allow me to go back in time and fix a problem up to 30 days later. Because there's nothing more joyful than your CEO or your finance director walking past you going, a week and a half ago, I was in the London office and the Wi-Fi was rubbish. And you go, why didn't you ring me a week and a half ago when the Wi-Fi was rubbish? Well, actually, I know his MAC address, I know his asset number, I can type that in there. But what I've got to do now is I've got to do something. I've got to find a way of looking at those packets, analysing those packets and finding a fix. This guy, in my opinion, is a proper Wi-Fi superhero. Click. Yes, thank you. He's had nothing to do with Arista. I might have bought him a beer once. His name's Peter McKenzie. I really want to shrink him down and put him in an AP. Okay? How cool would that be? Okay? Peter came up with a really valid point earlier. We all need to educate our engineers and our partners, and we all need to work together. But if I can do some of this and I can stop wasting engineers' time for fixing silly stuff, and we can look at the really hard stuff, then our time, our effort, and our resource is not wasted anymore. The story about me sitting in the car is a true one, and I suspect lots of you have done the same sort of things to fix silly things. We've also had to go out and fix really hard things, but it's the silly ones that just, challenging. So, like any good Marvel superhero movie, we have one more slide. So, this is a video I made of our system. This is a live system. You can see that we've got 1,200 clients on the network. I'm just going to go to that performance box, that one I showed you earlier. I've got low data rate clients, I've got high retries. And I'm going to select the ones with low RSSI. And if you look to the, you'll be looking at it that way, the right of the screen, I'm going to select this little robot head. Because in 8.7, this is what we're going to do now. I'm going to give you the capability for the system that has used big data analytics and capturing information to give you an answer to your problem. So now, hopefully, and I did write this well, it says, I found 75 out of 79 clients with the problem, and they're in the New York office. And actually, these clients seem to have an RSSI threshold problem. It gives me a clue. I'm not saying this is totally infallible, because it's not. But what it does is it allows me to have some form of concept or idea as to exactly what is going on with the network. So instead of me guessing, sticking my finger in the air, working out what direction the wind's blowing, I've got an idea, I have a concept. I can fix things more effectively. And on that note, I have 1 minute left. Get in. Do I have any questions, or can I run off the stage now, or? Fine. Thank you very much.